Morning. I am Dr. Usha Rani, Professor, S&H Department, RMD Engineering College. I am going to brief about the topic of operational amplifier, which will be useful for the application side, summing amplifier, or you can say adder. Taken one of the problem. The circuit shows the summing amplifier, which is having a 3 inputs and 1 output. Okay. I am going to brief about the summing amplifier. Generally, the operational amplifier, in this case of the application of summing amplifier, takes multiple inputs and only one output. So this will be useful in the case of signal processing, analog computations, that is addition, subtraction, multiplication, everything in the analog computers, active filters, wave shaping, analog to digital converters, integrators. If you see the basic operation here, this shows inverting summing amplifier. Why we are saying inverting summing amplifier? As here the inputs in this case is connected to the inverting terminal of the operational amplifier, that is the negative terminal, and a feedback resistor is connected from the output to the inverting terminal. So that's why the name is inverting summing amplifier. We can have non-inverting summing amplifier also. In that case, the inputs are connected to the non-inverting terminal, that is the positive sign. Okay, and feedback resistor is connected from the output to the non-inverting terminal of the input. That is second method, non-inverting summing amplifier. And a recap of the virtual ground concept is, we know that operational amplifier have a high gain, that is 10 power 5 to 10 power 6, and negative feedback. The inverting terminal is maintained at a virtual ground, that is this terminal potential is approximately equal to 0. So in this case, we are considering the circuit diagram of inverting summing amplifier. And we are going to find out the output voltage for the given values of V1, V2, V3. There are 3 set of readings given, and we are going to find out the output for each case. So for inverting summing amplifier, I have taken the formula of V output as minus sign of V1 by R1, that is the first resistor current, okay, and second resistor, that voltage divided by R2, V2 by R2, plus third resistor if you consider V3 by R3 into the feedback resistor RF. This is the general formula for inverting summing amplifier output voltage. So this is the general formula we are going to apply in each case, that is 3 cases are given. So case 1 I have considered V1 as 10 volt, V2 as 0 volt, V3 as 10 volt. That means here 10, 0, V2 and again 10 volt. In this case, I am just they are given the R1, R2, R3 values in the problem, and field resistor value 1K. So I am just going to substitute the values. So in this case, V1 by R1, so 10 divided by 1 kilo ohms 1 into 10 power 3 plus 0 volt as given for V2 divided by 2 into 10 power 3 plus V3 as 10 volt divided by 4 kilo ohms, so 4 into 10 power 3, close the bracket, and RF value as 1 kilo ohm. So I have substituted. If you simplify this, the answer as V output as minus 12.5 volt. This is the case. Similarly, we can go for second set of readings. Second set of readings as 0 volt V1, 10 volt V2 and 10 volt V3. So I am going to substitute these values for second case. So if I substitute these values, V1 as 0, V2 as 10 and V3 as 10 volt for the same formula, and after simplification the answer as minus 7.5 volt. Then third case, we are going to substitute V1 as 10 volt, V2 as 10 volt, V3 as 10 volt. So for the same formula, using these values of V1, V2, V3, each 10 volt given in the question, we have substituted and simplified the answer as minus 17.5 volt. So this will be useful for analog computation, summing amplifier or adder, which is useful for analog computation. Thank you.